Hello, my name is Jennifer Sills Almeida. Today I'm going to talk about the independent sample t-test. So for the independent sample t-test, what we are going to be doing is looking at two different groups. For the research question I would like to pull up for us right here would be, is there a significant difference in math scores between students who received intervention and the students who did not? If we're looking at this, what we're trying to gauge is, does intervention help or does it not help? Right? Is there a significance difference? Not really what that significant difference is, but does one exist? So on our, the first thing that we have to do for deconstruction is a verb analysis framework. We have to look at, is there a difference? And is it in between, which we're talking about? Yes. Is there a difference in math scores and then between students who received intervention and that have not? The intervention status, yes or no, would be the independent variable. It is categorical because it's nominal and it has two independent groups. The dependent variable is a math score, and the DV measurement, so dependent variable math score, is continuous at ratio level. The test selection would be one sample, so it's being compared to another, so that's an independent sample t-test. Now, for the next step, we'll look at steps 1 and 2, hypothesis and alpha. So the hypothesis, the null hypothesis is that there's no significant difference between math scores in these two groups. So whether they had interventions or not, that would be the null hypothesis. And here it is, the symbols for it. For the and it equals means that there's no difference. They're the same. And for the null hypothesis, the alternative hypothesis is saying that there is a significant difference between students receiving intervention and students not receiving interventions. The directionality, we're not really predicting direction. What we're trying to say is, does a difference exist? The alpha level is at 0.05, so that means that with this threshold, we're willing to accept a 5% risk of a type 1 error, and concluded that there is a difference when actually one does not exist. The three assumptions that we're going to be looking at. So the first thing that we have to look at is continuous dependent variable. We know that we have a math scores ratio levels 0 to 100. That's how it's scaled. 2 is independence. We've met this because we know that each student is either they're part of the intervention group, so they're either in intervention or they're not in an intervention group. Now, normality, what we're going to do is we have to check normality. That is one of the assumptions. So that is what I'm going to show you. The first thing that we'll need to do is I would like to go ahead and go into, just need to show you real quick, this is the data. So what we're going to be looking at today is the data that will originate and give us an idea about where we stand. So over here, let's go to Analyze and Descriptive Statistics, and then we'll need to go to Explore. There we go. Okay, so during this, I can move this back. What we are looking at and stuff would be the math score. Okay, so we're pulling this up. We are going to be looking at the math score. Great. And then on the factor list and stuff, what we're going to be needing to do is we're going to be looking at interventions. So we have to pull the interventions here, right? So we're seeing if, do they have interventions or do they not? Then we go to plots. We have to do the histogram. We want to not use stem and leave. We want to use histogram, normally plots. Normality plots with tests is what we're doing, and factor the levels together. We hit continue. Then hit OK. Okay, now for this and stuff, let's go ahead. Let's go ahead and look at this. So when we go up here, I have to go way to the top and stuff. So for this one and stuff, what we do need to do, what we do need to look at and stuff is the test for normality. So over here and stuff, we do see that's violated because it's supposed to be 0.05. And what happened is it should be under 0.05, so it shows that it's significant. So if this is this is the case and stuff, it's violated. Also, if the test is robust, in this case it is robust, but the thing is we need to look at it from the standpoint of if we had to look at another variable. So if we have to transform the variable and see what that is, then we need to do that if the normality is violated. So over here, I'm going to show you how to do that. And just real quick for the math score, the mean of the math score and stuff with no intervention is 85.95. The mean score with the intervention is 87.23. So it's only 1.28% difference on that. The skewness and stuff is at 0.668 and kurtosis at 0.313. So if we go here, we're going to transform. And if we go to transform, and what we're going to do is compute variable. So we are going to do a variable with a mass score and stuff. I have put it in here, mass score transformed. We're going to take the square root of what if they, assuming they had 100 plus 1 minus what their mass score would be. We're trying to see what that variable would be. And that was calculated before. I'm going to hit cancel because it is calculated and I don't want it to be recalculated here. So when we did that and stuff, you have a transform variable and it is to check the normality. So and the reason why we'll run a test on this and stuff is if it is transformed, we're trying to check the skewness, right? So skewness should be like equal, like right here, going straight up and down. So now when we're looking at the means and stuff, and we are trying to run analysis on that, once we have it, that transformed variable, we can go to analyze, and we need to go to descriptive analytics and explore again. Okay. Now what we're going to want to do and stuff is do it a little bit different. We need to take the mass score transformed. So let's just move this back. We need to move this back. And now we're not just looking at the mass score, but we're looking at the mass score transformed. So we're checking for normality. So right here, mass score transformed. We would put that in there. Great. Now what we're going to do is run the plots. We have it as normality plots with tests, histogram. We're good to go there. And then we would hit OK. So now we have the test of normality on it, and we also have the histogram and the QQ plot and the normal plot over there. So now what we're going to have to check for is the homogeneity of variance test, Levine's test. So we are going to need to now do something a little bit different. We're going to go ahead and pull up the independent sample t-test. In order to do so, we have to go to analyze, and we're going to need to go to compare means and proportions, and we are going to do the independent sample t-test. Now for this one and stuff, what we're going to do is we are first of all going to want to look at the mass scores. So let me just put this back. Now this will be the regular mass scores, right? So let's go back over here. We'll put that in there. Now this intervention level, the groups are defined, but this is how we'll define it. Group 1 is with the intervention. Group 0 would be with no interventions, right? So we're trying to compare to the two. What would these two groups be, right? Okay, so now for this, we have our t-test. So when we're looking at everything, we have to look at the mean, the standard deviation, what is the difference between the two. So right here we know that if they have intervention, then the scoring is at 87.23. No intervention is 85.95. So that's not a huge difference. It's like 1.28, but that's where it is. The standard error mean is 0.330, and for yes intervention and no intervention is 0.208. Now, it's very important on the independent samples test that when you're looking at this, you'll have to, for the Levines, you need to look at it and see which one do we to analyze. Well, this is equal variance is assumed, and you will want to be looking at that one for the independent t-test because there are two different groups, and the F is 2.088, and this one is 1.149. The T is 3.3, and we have two-sided and stuff, which is less than 0.00001. And the mean difference here is 1.28. So that means between the intervention and non-intervention, that was the difference in the scores. Cohen's D is very important. Cohen's D over here kind of shows you. So Cohen D kind of gives you an idea. I'm going to show you what it's at. It actually calculates it itself and stuff, but it tells you the 95% confidence interval for the lower and upper. And I am going to show you one more thing. Go back over here. So for the normality, we checked the normality. We also went to the Levine's test. We checked that. So for the variables, we had to transform it because if the normality is off, in our case, it was robust group of it was. The t-test was robust, but if it wasn't, it was less than 30, you would have to do that, mass score transformed. In order to get another variable, we ran the analysis. We assigned groups 1. When we were doing the independent t-test, we assigned the group 1 to the ones that had intervention, 0 to the ones that did not. We have to make a decision. So on this make a decision for Levine's test results, we used the first row of output, which was over here, right here, first row of output on the Levine's test. And what we did and stuff is we saw that there was an equal variance assumed. And for the p-value, we know that the p-value, this is really good in the analysis, but whether or not there was a significant difference. So the p-value showed that there was a significant difference because it was less than 0.001, which was less than the alpha set at 0.05. We had to reject the null because of this, and because it's 0.001 is less than 0.05, we had to report and interpret effect size. So we're looking at Cohen's D. Now, this is something else. We have to say it's one more thing that is significance, but also it's another whether or not the effect size will be small. So is it small? Is it large? What size is it? So here in Cohen's D, when we calculated it, Cohen's D was very, very small, saying the effect on actually the scores and what the students are doing is small. So it is at 0.12, which was small. So, and it was really below the threshold of 0.20. So, what our results and stuff, what we're looking at is that we're comparing these scores. So we're comparing these scores over here. Mass scores. Let me see. Let me go back here to show you. Okay. So if we're looking at the scores and stuff that we have over here, it will be t-test. We have it as a mean of 87.23. With intervention, 85.95 with not intervention. Well, that's not a huge area between the two. So this is where it comes into play. Okay, is this going to be is this magnitude going to be significant? So when we're looking at that, we have the students with interventions and stuff. So they actually, sorry, the math. Students that had interventions, their mean was 87.23. The ones without intervention was 85.95, standard deviation 10.55, and for standard deviation for the students that had intervention 10.79. So the difference was statistically significant because of the p-value, and so we had to reject the null. However, it's good to make note that the effect size, so even though it was significantly significant statistically, the effect size was small because of Cohen's d. So we know that the effect size was only 0.12. So over here, it was 0.12 because the score wasn't that different between the two scores. So the p-value of 0.001 shows the difference is real, but that Cohen's d shows the difference is small. So it was very, very small difference, right? Because 1.28 between the ones that had intervention and didn't have intervention is very, very small magnitude. So, but the practical significance of this is that even though the statistical significance does not equal the practical significance, this is why Cohen's d is good to look at and stuff, because yes, we decided on the p-value and stuff. There was a significance difference, but we have to know what is that mean difference. Was 1.28, which isn't much. So what this means and stuff is that when we're on a scale of 40 to 100, and we have a student that has an 86 and a student that has 87, that it's not a huge and meaningful difference. So in this testing, we had over 3,600 students. So our p-value of 0.001 tells us the difference is real, but it's unlikely due to chance. However, the effect size of 0.12, again, because the scores were only 1.28 difference in regards to intervention or not intervention, it's too small. So in this sense and stuff, what kind of instructional decisions would we make? That's something that an educator would have to think about. We could do the intervention, but it wouldn't make a huge difference. So it was a pleasure speaking with you today. Again, I just wanted to, go over, like everything, the numbers again. So for this math score, 1,070 students had the intervention, 2,565 did not. So it's about 3,500. That's where that comes from. The score of people with the intervention was 87. Without was 85. The independent sample size it talks about here, we're talking about equal variances, and and here you can just kind of see the difference between the means between the groups with no intervention and the groups with intervention is slightly higher, and the skewness was brought down by having that transform variable. Thank you so very much. You have a great day.